So lean systems and different aspects associated with lean systems, what goes on there. So we'll just go over the content, review it, and then also take a look at the articles that we have for this week. So lean systems, we did see this term before. So this time we are formally understanding this entire area of lean systems for those who have not come across this before as part of your work. It's something which comes from manufacturing context. It originated in Toyota, and then from Toyota within other auto companies, and then from automotive industry to other manufacturing companies. And over time, it has moved into services, including healthcare. So we look at lean systems as a way or as a philosophy to manage processes so that they're managed in just-in-time basis, and we reduce potential wastes that might be there in the system. So there are different types of waste that we are examining and trying to eliminate, while at the same time maintaining the quality, safety, and other considerations that needs to be there. So lean systems differ from Six Sigma total quality management in the sense that Six Sigma mostly is more micro focused. It is quantitative technique, looking at a single process and improving it, mainly in terms of variability reduction. So the objective in Six Sigma is to reduce the variability in the process. And that's the basis for improving quality of a process. Whereas in lean systems, what we are interested in is look at the overall system level activities going on, and then understand how things are being done and why some of these things might be even needed if in case there is some redundancy that we can see in the overall system view. So lean systems takes a more macro perspective compared to Six Sigma. When Toyota production system was created, they had so-called, sort of a house of Toyota. This is what they call for what you see here. And the main idea here is that it has grown over time organically. So this is not like something which was designed and then implemented. It organically grew in a way that eventually they made it more formalized within the company. Showing that the two main pillars for whatever happens in Toyota are lean systems, where you can see aspects like flow, managing the flow of parts moving between workstations. And we can obviously connect that with healthcare, as in movement of supplies, medical supplies, but also movement of patients between different processes. How do we manage that in the most effective way? Hijinka, which is managing the process in such a way that it's sort of a balanced load. It balances across different workstations at any given point in time. And there are certain other terminologies that we will see as we go forward. So there are certain concepts that come under lean systems, and they are used to make a given system go through this sort of a lean kind of approach of managing it. And then Jidoka is sort of mistake proofing. It's a way of managing the process so that you avoid mistakes, because the process does not allow mistakes to pass through. It could be by creating systems or parts within manufacturing context that always fit in a certain way, and any other way, if you try to fit it, it will not, and therefore it's mistake proof by design. And similarly, in service organizations, companies have thought of managing these services so that they can always only be managed in one particular way. And if you try to change it, then there are certain issues that come up, and hence it's terminology called PACU. So terms that I have kind of explained a little bit in the video. So I don't want to go in all of these terms in further details, but I just wanted to emphasize that these are the two pillars: mistake proofing and the lean systems. The goal being customer focus. If we translate that in healthcare, it's patient focused. And then the foundation for creating the system is standardization. You want to standardize work as much as possible, Clearly, in many contexts, standardization is not always possible, but as much as possible, you want to standardize parts, supplies, the way in which things are done. You're using some Kanban A3 thinking. A3 is essentially in one page trying to structure all these different things that are going on in a process through checklists and other things, whatever might be needed, like a visual display of what's going on. And then that helps in standardizing what's going on in one set versus the other set of process. And then the other one is stability, which is through total preventive maintenance. You create maintenance schedules on a frequent basis. You are standardizing work here also. You have a question here? All right, so these are concepts which we are using to stabilize the system. So those create the foundation for the lean system to work. And that's how the overall Toyota production system works. And that's been translated into services and healthcare. Now, coming to terminologies, as I said, there are several terminologies that are in lean systems, one of them being Kaizen. And this term is used for changing a certain process for the better. And this is where you look at a certain process that requires change, because clearly, after looking at the entire system, you found that there were certain processes that need some work, whether it's in the form of process improvement, whether it's in the form of process redesign, things that we covered in the first week. And that activity of process improvement and process redesign in practical sense is done through these Kaizen blitz or Kaizen events, where cross-functional team members will come together, and there will be a few steps that they'll go through. First, they will specify what is value, how is it defined within that process. You map and improve the value stream. So for a given set of activities, what are the different flows that are happening, and how can we improve that flow? You facilitate that flow, allow for a pull-based system. So what the pull system does is you only move things forward to the next workstation or next department when the department calls for it. When this customer department is actually asking for some things to be moved forward, that's the time when it's sent forward, not in a push-based system, but a pull-based system, and enable perfection. So sort of a Kaizen is process improvement event, which is targeted at a certain process that has been identified as one that needs improvement. Value stream mapping came up as we were discussing Kaizen, and that is essentially a pictorial representation of the entire process flow. So unlike the process flow chart that we looked at in week one, value stream mapping, what it does is it looks at the flow of products or patients or whatever the actual movement of physical, tangible thing is. But then it also captures the flow of information. And finally, at every step, it tries to distinguish between the value added time and the non-value added time. So, and the way we define a value added step is, does the patient care about the activity? If not, it's considered to be a non-value added step. And one needs to figure out a way to reduce the non-value added time in the overall system. So for instance, I mean, this is just an example of patient getting admitted, going through triage, labor and delivery, postpartum, and then discharge. And there are certain wait times in between. So what we see here is that there's a flow of the patient through different departments. Then there is sort of an information flow going on, which is what we see in the form of these arrows that are shown here. And that information flow then brings required, like for example, supplies or housekeeping, radiology, whatever might be necessary at different departments. That information flow is going there, and then things are happening over there, and then potentially it's being brought back for use for the patient care. So once we are able to pictorially represent all these things, let's ignore these sort of lightning bullets that we see here. These are essentially something which are requiring improvement. So these things come later in the overall representation. Earlier, we only have everything else except these lightning flashes that you see there. And at the bottom, what we do is we present at every step how much time is being spent. If it's wait time, how much that is. If it's admission time, how much time it takes for the admission process to finish, the triage to get over, etc., etc. So anything that we have in that lower end of these, this particular sort of a figure that we see at the bottom, everything that we see at this lower end are value added activities and the time that it takes for those value added activities, because these are directly influencing patient care. And anything which we see on the top here are the ones which are non-value added time. And overall, we know what the total time is, which is the combination of value added and non-value added time. And the objective for any organization is to increase the proportion of value added time vis-a-vis the total time that is being used up in all these processes. So that's something which you can see by pictorially presenting it, how it is currently being done. And then once you realize that there are several areas where there is opportunity to improve, then you're trying to see what are the causes that could result in potential delays or non-value added time. So it could be because of incorrect patient forms, it could be because of rooms unavailable. So all these are essentially the reasons why we're not able to achieve a higher proportion of value added time compared to the total time. So once we figure out some of these reasons, then one starts getting into the Kaizen events for managing anything which, whichever one we think is the most bang for the buck in terms of effort that we will put in to improve it. So that's the way we use value stream mapping. And we'll see later in one of the articles, we have a discussion of an organization which has gone through value stream mapping and the benefits that they received by going through it. Now, when we go through the creation of value stream mapping, there are certain technical terms that come into play because one part of this is to just pictorially show what the current state is. So this is the current state of your admission process and the entire set of activities that's going on here. But then you want to go to a future state, which is an improved state of what you are seeing here. And the way one goes from current state to future state is by going through certain calculations of what is the right way or what is the better way to do it. And one of the important concepts here is what we call the tact time. And tact is actually a German term, which basically means beat. At what beat should this process complete a service or make products, whatever the situation might be. So essentially, it's the speed with which customers must be served to satisfy demand for the service. So it is something which is dictated by the demand on a given day or a given month. So for any given system, the takt time will be defined upfront because we know approximately what the demand looks like in a steady state situation. And then we know what is the available work time per day. So both the numerator and denominator has to be in the same unit. So if it's days in the numerator, then denominator also in days. If it's weeks, then both should be in weeks. But we know what the available work time is per day, what the customer demand approximately is per day, and it's a ratio of those two. And it's sort of similar to the idea of cycle time, which we saw earlier in the first week, but this is for the entire system. It's not for one process, but the entire system. What exactly is the time that you want to achieve in terms of the speed at which things should operate as against how it is operating? So it's sort of a ideal state scenario that you want to reach, which will then help you create the future state. So it provides you the basis for creating the future state. So that's one term that comes into play to go from current state map to future state map, because you've made this picture, you know there are certain problems here and you want to eliminate them. But then what is the target that you're trying to achieve? That's defined through the takt time, at what pace things should happen. And that's something which you can calculate here. The other term which we use is throughput time. You have seen this also in the first week. This is the time for an item to complete the entire process. So this would include the wait time, the transport time, actual processing time. So everything value added, non-value added, everything put together is what you will have as your total throughput time. So as an example, if you take a clinic and you try to understand what the cycle time, throughput time, and takt time would mean for a clinic, a patient checks in, takes 3 minutes, let's say, wait time is 15 minutes after that, moves to examining room, about 2 minutes in that movement. A nurse does the preliminary examination, 5 minutes for that, wait time of 15 minutes, physician examination and consultation, another 20 minutes, and a wait time of 10 minutes and visit complete. So very simple process, just to illustrate the idea of cycle time, throughput time, and takt time, mainly takt time here. So we know the patient check-in time is 3, and the system cycle time is the longest time. We have already seen it in the first week. That's the bottleneck that dictates what the system cycle time is. That's 20 minutes. And the throughput time is the sum of all the times that we have listed here. So 3 plus 15 plus 2 plus 5 plus 15 plus 20 plus 10. So all of them put together gives you 70 minutes. Now, to understand what the takt time is, which is how much time ideally should the physician minutes per patient be, how much time they should be spending, we take the available time, work time per physician in that clinic. So let's say the available work time per physician day is 5 hours. So clinic physicians work 10 hours per day, but only 50% of the time is spent with patients. So that's why it's 5 hours available work time per patient physician. And clinic has 8 physicians, and 100 patients are expected at the clinic every day. So if we have this basic information about the clinic, we can find what should be the time that in ideal state, in whatever the future state we want to create, the physician should be spending with the patient, and that's 24 physician minutes per patient. And that becomes sort of a basis for what needs to be changed in the given uh, situation here. So right now looks like the overall time that the physician is spending with the patient is sort of less than the 24 minutes that you want for takt time, but it at least gives you sort of an indicator that when are you going over that time and what needs to be changed so that you can achieve the required takt time. All right, so any questions regarding just the basic ideas of value stream mapping? So value stream mapping by itself is a big area which requires at least two weeks worth of discussion. But right now we are interested in understanding the basic idea of how it can be utilized. And then those who are really interested in it can also dig deeper into available material in the articles, as well as some of the supplementary readings that I have for the week. But I can answer any question you might have regarding what we have done so far in the discussion. I'll take it as there's no question. I'll move on with the next topic that we have covered this week, which is the Lean tools and Lean Sigma. These are tools that are used along with value stream mapping, which then help organizations become lean. The first tool is something which we saw in the last week also, the 5S. And these are 5S coming from Japanese terms, but they correspond to these terms in English. So sorting things in the right way, setting it in order, which means arranging them in the right way such that the necessary items are neatly available as and when you want them. You can easily go and pick them up. To clean the work area, standardize, and then sustain what you are achieving here. So these are the 5 S's. In one of the articles, we had seen how they were achieving these objectives of 5 S's in that particular situation. So that's one tool, sort of a conceptual tool, which then helps guide organizations to do things that can address these 5 S's in their lean journey. The second is spaghetti diagram, which is a visual representation of how material employees, customers, patients are moving through the system. And what you're trying to see is that if there is too much of divergence in the process, if there is too much of um, movement going on from one point to the other, there's a layout issue here, and that needs to be fixed. So that helps you understand if there is too much time being spent in movement because of the way the layout is, and that then helps in restructuring the service design, and then therefore help in creating a lean system. So that's another way to do this. Another tool, Kaizen events, we talked about this, so I'm not going to go again into details of that. It's basically process improvement at a particular process. Standardizing work, we saw this as one of the foundational requirements for the Toyota production system. And there's a written documentation of the way in which each step should be performed. It's not necessarily a rigid system, but a means of communicating and codifying. So it's a way to structure different activities and make sure that there is some way of codification. So codification can be the form of care paths, essentially an optimal sequencing or timing of interventions, which can then decrease delays or resource usage. There's some examples. You'll see many organizations that have used these standardized processes to reduce the time that it takes. Jidoka, I had mentioned earlier, it's essentially error proofing concept, but the literal meaning of Jidoka, which is again a Japanese term, is the ability to stop the process when the person who is working on a process identifies that there is some problem or there's some issue in what's being done. So in an auto industry, for example, when it's a assembly line, any worker who sees that there is some sort of some incorrect thing which is already on the car and it's moving forward through the assembly line, and they are not directly responsible for what exactly has happened there. Maybe the paint is having some sort of shade differences than what it should have, or any of the other issues that could be there. Then that worker, irrespective of whether it's their responsibility or their job, they will stop the line. So it's the ability of that worker to stop that line, assembly line, and then every worker will come to that spot where this line was stopped to see how it can be addressed. So same idea can be then applied in other contexts, including healthcare services, when one realizes in sequence of steps that something doesn't look right, then instead of moving it forward to the next step, one needs to fix that process so it prevents defects from passing from one step to the next. So that's sort of the basic idea of Jidoka. And Andon is again a tool that is used. It indicates that there is a problem in the process. So it's connected with Jidoka, that whenever the worker is stopping the line, it signals to everyone, whether it's in the visual form or an audible form. And that's what gives the cue to everyone to come to that point to fix the problem. So it's sort of a visual cue. We have seen the term Kanban, and we have talked about it in two-bin inventory system, which is sort of a Kanban system where you are signaling when one of the bins is getting used up, and then you use the second one. It gives a signal that it needs to be replenished. It's the same idea, which can be also applied in process flow besides inventory management, where you have customer process and then you have certain workstations that are supplying to the customer process, because in every organization there'll be internal suppliers and internal customers. And this Kanban is literally a signal, and the signal goes from the customer process to the workstation that is supplying to the customer process, indicating that the customer process now has completed what it was doing in the previously, and it needs the next work to be moved forward from the workstation which is its supplier. So it's sort of a signal to task to workstation to send the next patient or whatever the process might be doing here. And in the healthcare context, for example, the CT scan and echo could be places where patient has to go and to manage the flow of patients between these two processes. you could create signaling between these two stations so that the patients are moved forward from echo to CT scan at a pace which then is consistent with how CT scan will be able to manage them in terms of its requirements. So it's a customer process, and this is the supplier, internal supplier for CT scan. And the signaling is either electronically or some other format. It could be even actually cards that can be used for making those signals flow between these stations. So those are examples of Kanban concepts in action within healthcare, including Tubin inventory system that we saw. The next tool which we use in lean systems is called the single minute exchange of die. So essentially it's called single minute exchange of die because in production environment, there are these big die machines which took multiple hours, sometimes days, to really change from one die to the other so that the next product can be made. And that created a lot of delay in production. And then what Toyota had to do, because ultimately everything originated there, was to find a way to reduce the hours or weeks that it takes or days it takes to change the die into a single minute exchange. So it should not take more than 10 minutes to change that same die. So whether it's through some sort of a pre-processing activity to be done, some setup time reduction that can be done. So they actually were able to achieve that reduction in many of their processes of die change, which then made other organizations start looking at their own activities, which took a lot of setup time. And they also found that actually, if you look at them carefully, manage them in a way where some of these setup times can be reduced by bringing things in advance, you can achieve single minute exchange also for their operations. So in healthcare, I think surgical processes, for instance, the preparation for surgery can happen in such a way that the setup time does not delay the surgery. And that is sort of an example of something like a single minute exchange of die, that you need to bring the process related supplies in advance. You prep them in the tray, and then the surgery should be ready to go. So it's sort of streamlining all setup activities. That's something which can be done in healthcare also. Then you have the flow and pull concept. We looked at this also in the house of Toyota. You try to create a continuous flow as much as possible. The whole idea of lean systems is, as much as possible, it should not go through big batches. You should have a continuous flow with one patient moving from one station to the other station in a sort of a flow as much of a continuous basis as possible. And if it's not possible, then you need to find a way to create a certain batch which is small enough. And that's where Kanbans can then help in moving small batches of parts or patients or whatever you are moving forward into the next station. The idea of just-in-time and pull systems, we just talked about that. And then Lean Sigma, there is an article related to Lean Six Sigma this week. These are two different concepts I did mention earlier. Lean systems are more qualitative. They are meant to eliminate waste, achieve flow and pull-based system. Whereas Six Sigma is a quantitative technique, statistical technique. It is meant to eliminate defects and reduce variation in processes. And that's something which sometimes get combined, and organizations use both of them, which then help them achieve, using the advantages of both, achieve both the elimination of waste and elimination of defects in the kinds of activities that they're doing. So you'll see Lean Six Sigma many times being implemented in organizations as a combined activity. So that's your content for week 4. I have gone over most of it in a sort of high overview, but you have some details more in the videos that are uploaded. So make sure that you go over them. For the articles, these are elaborating on what we just talked about. For instance, the first one is application of lean thinking to healthcare issues and observation. It's a broad stroke on lean thinking in healthcare. puts in perspective the evolution of lean thinking. We talked about this a little bit, as in earlier it was mainly in automotive industry, and that too in Toyota. From Toyota, it moved into other auto industry companies, both the OEMs as well as tier one suppliers. And then from there, other manufacturing companies beyond auto. And now we have this being applied in even service industry. And the focus has also started to move from what it used to be very highly prescriptive to something which is more integrative. It uses more of a management thinking in today's world. The article highlights the principles for lean thinking. And there are 5 principles. Provide the value customers actually desire, so what the patient wants. Identify the value stream. We talked about this, that whenever you're trying to improve something, you need to understand how does it get executed? What are the different steps? Can we create a pictorial representation of current state? And determine where there are wastes, non-value added activities, and can we eliminate them through focused Kaizen events. Principle 3 is to line up the remaining steps to create continuous flow. You're trying to achieve continuous flow as much as possible. Pull production based on customers' consumption. So talked about this, that the customer workstation should dictate how fast the previous process should work. And start over in a pursuit of perfection. So you're trying to reduce waste, and that's something which then makes perfect value to be achieved by the system. Some considerations, there are operational considerations, basically that focuses on the variability within the system, natural versus artificial variability that you're trying to address. Socio-technical consideration, which is where human beings have to do things, and when you expect them to do everything just in time, it can add stress into their activities. So one needs to understand that this is a socio-technical system, and hence the human part of the overall equation needs to be also understood when the value streams are being managed and improved. The idea of cumulative capabilities, which means that you can build on different capabilities. For instance, if you improve quality, costs can come down, because earlier one used to believe that whenever quality has to be improved, cost always goes up. But over time, organizations have shown that many times when you improve quality, costs actually can come down too. So it's a benefit on two ends, sort of a cumulative capability development for the company. And that definition provides a definition of lean thinking, an integrative, operational, and socio-technical approach of a value system whose main objectives are to maximize value and thus eliminate waste by creating cumulative capabilities. So it sort of provides a framework of how both of these aspects influence performance. Then you have value adding and non-value adding times, examples, when you are not actually adding values. And I'm not belaboring this point. I know that from what we just saw in the previous discussion, sort of it's clear as in where exactly the non-value added activities many times are. Most of the time it's the wait time, administrative time, which is not directly involved in patient care. Now, the next one is Healthcare Lean Six Sigma system for post-anesthesia care unit workflow improvement. So this is an example, it's a case study at a certain healthcare organization. And this one provides example of how they went through it and what the advantage they received. Starts with this idea of what are the factors that influence healthcare quality based on the Institute for Healthcare Research and Improvement. There are 6 different factors: safety, timeliness, effectiveness, efficiency, equity, and then the patient care should be responsive to patients' individual needs. And so these are the 6 ones dictated by or prescribed by Institute for Healthcare Research and Improvement. It highlights some of the tools, as we saw earlier, the A3 reports, 1-page sort of summary of what the process is all about, value stream map, the house of quality. It presents an idea of house of quality, how that can be used. Essentially, house of quality is, from the customer's point of view, how do they define quality? What are the measures that they consider important for the service to have so that it can achieve their required quality levels. And then Six Sigma also, kind of some of the tools that are necessary sometimes in lean implementations. It also emphasizes that to be able to have a successful lean implementation, top management needs to give the quality improvement team the time and financial resources, because many times that top management support is the key driver, and that's the one which either makes it successful or not successful. Something which I've seen in one of the research that we did, which included healthcare organizations also. So we did Six Sigma and lean implementations across 11 different organizations. And one of the important defining factor was the problem definition, and the second was the top management support. And then have an organization level understanding that different quality improvement teams can construct different A3 reports. So it's not like a standardized A3 report. It's not necessary that every single report should look sort of identical. There is enough reason to believe that there will be different types of A3 reports that can come from different teams. Distinguishes lean and Six Sigma. We have talked about this, so not going into that. And then emphasizes the sequence through which organizations can implement Lean Six Sigma. So the first step is to identify the stage, which is identify the quality improvement goal by hearing the voice of customer, which is what exactly the customer believes is important for them. What are the quality indicators which they consider to be important? Select the team members at this stage and accomplish the project charter, which is the definition of the project, the boundary of the project. The second is the analyze stage, which is study and analyze the current state of your targeted process. This is the current state map that we talked about. So you analyze the actual process and measure the baseline, analyze the collected data to understand the present situation. The third stage is the action stage, which is to transform the voice of customer into countermeasures, which is the voice of the producer, which we call it voice of producer because now everything the customer wants as part of their quality expectation needs to be also viewed from the producer's point of view, healthcare provider's point of view. How do we deliver whatever that patient or whatever the customer is looking for from the service delivery process point of view? So you're operationalizing it from the producer's perspective. So that's what you're doing here. The countermeasures are the voice of producer, and then you implement them. And then finally, follow-up stage to see whether it's a sustained improvement or not. And so that's sort of the 4 steps, things that we just talked about. And then the tools that we will be using in different stages, they are emphasized in this particular article. So you can read them, but quite a few of them are similar to the kinds of things we have seen before, checklists and other things. Now, the application that they have is in the post-anesthesia care unit. And some characteristics that we have to keep in mind in post-anesthesia recovery is that it's a continuous process, and it only completes when the patient is completely well. And it requires one-on-one care. After surgery, surgeon has a wait list that extends care for 6 weeks. And then there are patients who are spending 95 minutes before transfer to the ward. And the nurses spend only 18 minutes on one-to-one care. And 77 minutes are spent on other activities, which are not directly for patient care. So then the next was to look at the current state. So they kind of mapped it out in terms of how the process is going through different stages and how much movement is going on, how much information flow is going on. At each stage, how much time is being spent, which ones are value added, which ones are non-value added. We can always create that sort of time line at the bottom to indicate the non-value added and value added activities here. And then looked at stage 1, the identification of quality improvement goal. They had 5-member quality improvement team, which included physician, which included nurses, IT, and the manager. They used quality improvement team surveys, and they interviewed the other staff members here. And through this, they identified that patients receiving spinal anesthesia should be awake in 30 to 40 minutes. And the quality improvement team concludes that efforts can be made to improve workflow and reduce the length of stay from 95 to 40 minutes. And the budget for the improvement will be 600,000. So this is something which was the preliminary boundaries creation for the project. What exactly needs to be done? Because we see that we have this 95 minutes of time that is being spent before transfer to ward. And through the discussion with the other staff members, they realized that it can be brought down to 40 minutes at an expense of 600,000. And later on, we'll see how this 600,000 is spread into different kinds of activities. At stage 2, they analyze the current situation, understand they're using the root cause analysis. So there was first problem they identified, which is nurse must leave patients to retrieve X-ray films from the viewing box. And the reason why this is happening is it's an inefficient layout of the PACU, sort of the spaghetti diagram that we saw earlier. There's too much of divergent movement for people providing delivery of care. Problem number 2 was the nurse must take X-ray films to the surgeon. Surgeon doesn't go to the PACU to read the X-ray films, no means to communicate remotely. That's the main reason. So if we can create that communication mechanism, then that can be reduced, and so on and so forth. So they basically identified 7 different problems, and for each of them, there's a root cause for it. In stage 3, they transformed the voice of customer into countermeasures, and then they implement them. So the countermeasure for each of these 7 problems, most of them, I mean, not all exactly one-to-one correspondence. Some of them can be addressed with one of these things that you have. So this translated into, these are the requirements from the customer's point of view. That is, improve the layout of the post-anesthesia care unit, allow the surgeon to read X-ray films remotely, reduce trips for supplies, etc. And to be able to achieve them, the countermeasures were the value of the voice of producer, which is the redesign of the service delivery process, to implement picture archiving and communication systems, apply RFID tags, and other communication protocols here. So that's the kind of conversion of the voice of customer into voice of producer. Then what this organization did was they created what we call House of Quality. Essentially what it does is it maps all the voice of customer. So you see the voice of customers are in the rows, R1 to R6 that we see here. And then the voice of producer are the T1 to T6 out here. And they survey the patients as in how much importance they consider for each of these 6 different requirements that they found as part of the customer requirements. So there's a rating from 0 to 10 in terms of the level of importance. And then they used a tool which we've not covered. It's a tool which can help organizations to create sort of a matrix of determining how much weight they need to put into different delivery of the producer side of things. So from the T1 to T6, which one should be given the most importance in terms of the first activity to be implemented, which one should be the next one, and so on and so forth. And so this values that you're seeing here, these weights that they're getting, is by applying a certain tool that then help them to understand which one should be the first activity that they need to work on. So T3, which is apply RFID tag, seems to have the highest weight here, followed by the next one here. So that's what they are achieving through that step. Once they get that weight, they are implementing it. And this, the article tells you that there is a tool that you can actually use. There is a technology that directly can provide you all these weights. And that then tells you what's the sequence in which you should be implementing different things. And that's the sequence that they followed. And then the advantage was that they ended up creating a new workflow, a new design for this entire process, which in the paper they highlight that it has reduced the overall time, non-value time, and improved the overall um, process efficiency for this particular organization. So that's an example. Now I'd like to sort of get from any of you who has gone through similar kind of an exercise in your organization, implementing something like this or something similar to this.
I can share one that in my previous organization in 2012, we added on to a large community hospital,
Mm-hmm.
which included new ICU units, but specifically around this example, because we actually did about 8,000 hip and knee replacements a year, and it was a very busy facility. We spent quite a bit of time at looking at the flow from patients literally coming in from the parking ramp through the hospital into the preoperative holding area, into the surgery suite, and through the recovery room, just because it was a matter of making sure that that flow was going to be very conducive to what would be easiest for the patient, because going to the hospital already is usually cumbersome and a lot of walking, a lot of challenges in navigation. So we spent quite a bit of time being able to make sure that we looked at how the patient perceived that
Mm-hmm.
experience, but we viewed it from the perspective of how is it that our workflow needs to enable that experience to be one that didn't seem cumbersome and overly bearing on the patient, because they're the ones coming in to have a surgery,
Yeah.
and that's already stressful enough. So we
Mm-hmm.
really tried to do it from a much more friendly perspective, if you will,
Mm-hmm.
than just what's easiest for us, because there's so much that goes into the mechanics of building a new wing or a new unit like that.
Mm-hmm.
And so we did quite a bit of the mapping out and the flow of this. In fact, we went through visiting sessions and being able to map it out, and then we went through identifying what were just do it's versus projects, and really put a lot of. In fact, everything we did was based around the lean management source tools.
So you did use these current state maps and value stream mapping and all those things?
We did. We actually, because we were moving the operating room and the recovery room to the new wing from where it was, we actually mapped out the current state of what we had. That included every bit of process design, the the registration, admitting units, all the way to how do the patient get to the
Yeah. Mm-hmm.
preoperative holding, identified what would be ideal. We wanted the voice of the customer to be able to tell us what is it that makes sense in this, the actual structural layout.
Mm-hmm. Mm-hmm. Yeah, that's great. So I mean, you have practical experience with what we've seen here, and something's new that you might learn here. I didn't go into the details of this entire thing, and I think you will be going over the article anyway. So the analytical hierarchical process that they are using here is a very useful tool, especially when you're translating the voice of customer to voice of producer, because ultimately many times these requirements that you see from the patient's point of view are a lot more subjective, but your implementation has to be a lot more objective in terms of dollar amount attached to different processes and different steps that you have to change. That translation activity sometimes is where um, not where care not a lot of care is being given, and I think that's where this particular article can give some insights as in how you translate the voice of customer to how you will actually translate into an actionable plan of action for the organization. This next article again looks at the Lean and Six Sigma methodology and improves operating room efficiency. This is a high volume tertiary care academic medical center This is Mayo Clinic. So Mayo Clinic, Rochester, with 88 main ORs divided between two on-campus acute care hospitals. One is Rochester Methodist Hospital, and the other one is the St. Mary's Hospital. All operating rooms are staffed exclusively by Mayo Clinic physicians, residents, nurses, and allied healthcare staff, which total about 4,000 people. The staff are employed under one organizational leadership structure with a unified policy and procedure manual for OR conduct. So this is what sometimes distinguish organizations quite a bit, and that also creates challenges in how much of this can be implemented in other places. Because I've seen organizations where many of these may not hold true, because Mayo Clinic sort of a outlier in many sense in terms of the number of physicians on their payroll as compared to many other healthcare systems. And on average, there are 53,000 to 56,000 operations performed annually. So the aim in this particular paper is in 2008, they took an institutional initiative to improve the operating room efficiency. So they decided to initiate a global assessment of patient flow from the surgical consult through post-operative recovery. And multidisciplinary leadership team was created. Surgeons were there, anesthesiologists, certified registered nurse anesthetists, registered nurses, administrative systems and procedures experts. So sort of all kinds of areas were represented here. They identified five work streams that contributed to the flow of surgical patients. These are the work streams that will have their own value stream map. And then smaller multidisciplinary teams were tasked to redesign their five work streams using Lean Six Sigma methodology. What the objectives for the work streams was: number one, unplanned surgical volume variation, to design scheduling processes that support improved operating room use, decrease the underuse and overuse of operating rooms. So right now they saw a lot of unplanned surgical volume variation, and that created issues with schedules and capacity usage. Number two was to streamline the preoperative process, which means to ensure appropriate patient testing and evaluation is being done before surgery so that redundancy of provider activity can be removed. Third was to reduce OR non-operative time so that it can make it more efficient. And reduce the collection and documentation of redundant patient information. And then employee engagement, which is improve employee engagement and satisfaction across all surgical service constituencies. I know you cannot see this current state map, but mainly what I want to highlight is that they also first created a current state map, which is the time of the surgical consultation, for instance, one of their value stream. So it captures all the different stations or different processes through which one has to go through, the information flow that is happening at each of these different stations. And likewise, you have a current state map for surgery and then discharge from a surgical patient at St. Mary's Hospital. So it's another work stream. So one, in some sense, this one follows the previous one. Once they have created these maps, they determine some key interventions for each of these different things that they had identified. Unplanned surgical volume variation, they had to find some interventions in the form of process improvements. So they developed surgical case scheduling system. So we talked about the master surgical scheduling in one of our previous weeks. So that's one thing that they did here. They did some standardization and that's sort of the set of things that you see in the article emphasized as in what has been done for that. The second was to streamline the preoperative process. So they mapped the existing clinical and financial preoperative process to look for redundancies and waste, and then implemented triage guidelines to ensure that the patients receive the appropriate level of preoperative evaluation before the day of surgery. So many of this setup time that we talked about, the single minute exchange of dye, sort of similar idea here that many times this can be a long time that is being taken, and you can pre-plan it in such a way that when the patient comes, the time is being spent on the care delivery. Third is reducing OR non-operative time. Again, some key interventions included evaluating current non-operative time performance variance. Then they mapped it to look for redundancies and waste, established some process definitions, standardized the activities of the nurse working in this OR unit, and so on and so forth. Then reducing the collection and documentation of redundant patient information. Again, most of them seems like redundancies had to be removed. And then employee engagement, they did staff survey results analysis, looked at 21 key drivers of employee engagement, and looked for ways to create shared goals. So these were some performance benefits that they got before implementing and post implementation for different types of surgeries: thoracic, gynecologic, and general and colorectal surgery. For each of them, most of them, I don't think they got benefits in terms of the operations post 5 p.m. Again, I don't think you can read this, but the first one is on-time starts, percentage of on-time starts from 50% to 80% in the case of thoracic surgery. So it's a substantial improvement there. And similarly for everything else, it's from 64 to 92, 60 to 92%. For operations past 5 p.m. that they wanted to reduce, not much difference, at least in the thoracic surgery, 34 and 36, but slight, I mean, actually it's significant from statistical point of view, 42 to 36 and 37 to 31. Likewise, average turnover, average staff overtime, operating room saved per day per specialty, and change in operating margin per operating room per day. For each of these measures, they found improvement for this kind of steps that they took. So that's the snapshot of the performance benefit, but then they also looked at whether they have sustained performance improvement over time. So from that baseline, they had improved initially, and then they found that it didn't drop after a certain quarter was over. That improvement that they received by implementing this Lean Six Sigma remained so for a sustained period of time. So that's sort of a validation that it actually can help in the long run. Same thing with other performance measures also. For this particular measure, looks like didn't really sustain as much for general surgery and colorectal surgery. The median room turnover by specialty did come down, but eventually it went up again. And then this one is again margin changes for each of them. There's an improvement, and then it remained. So for most of them, it remained the same, and for one of them, it actually increased even further. So that's the article there. And then third one is lean thinking transformation of unsedated upper gastrointestinal endoscopy pathway. So again, examples of different types. So I don't think I want to discuss too much in detail other examples as well, but just different contexts. For each of them, you'll see how the context defines the kinds of things they have to do. They also have current state map. They have steps in the current state and how much time it takes, just like we were doing in others. What is the minimum and maximum time it might take, so that we have an estimate of what's the minimum time it would take for the patient journey to get over and the maximum time. And this is like a summary of number of steps, how much time, etc. So that then gives them some understanding of how much the value added time is, how much the non-value added time is, which then helps them decide how the workflow from current state in a slightly better way of presenting what you saw earlier to a future state can be achieved. So what this paper highlights are some system redesign steps or changes that they have made from current state to future state so that some of those non-value-added activities can be removed. So this is their future state. And these are the things that they have done, right from reduced administration within departments. Patient's route has been changed to a cellular model, something which we saw in the rehabilitation hospital, the reading rehabilitation hospital case study. The kind of things that they were doing, something like a cellular model, the care pathway that they are trying to develop there. So this is their future state workflow. And once again, they emphasize the benefits in terms of value added time and other things.